Well, good afternoon, everybody, and welcome along to Data Platform Downunder for our first session in May. My name is Warwick Rudd, and along with Martin Catherall, our co-host, we bring to you for this session Will Valida, who's going to talk to us about developing our HTAP analytical solutions with Cosmos DB and Synapse Analytics. Just so that everybody is aware, this session is being recorded and will be made available on our YouTube channel. If you can hold your questions to the end, allow Will to flow through the session. And then if you do have questions, you can either put them in the chat window, which I will be monitoring, put your hand up, and then we can let you come off of mute and ask your questions yourself to Will. Now, we do have an announcement before handing over to Will. Some of you may or may not be aware, but Data Saturdays and Data Anzac is up and live. Now, the session will be running on June 26th. Ooh, some people are on. There we go. On June 26th. It is promoted. You can have a look at it. The URL is on the slide deck at the moment. It is running for 12 hours. We are running from 9 p.m. UTC on the 25th. That's why when you go to Data Saturdays, it will look like it is running on the 25th. But in our time zone, it is on Saturday the 26th. But we are running from 9 p.m. UTC on the 25th through to 9 a.m. UTC on the 26th. This way, we are actually covering the full time zones from New Zealand all the way to Perth. Free registrations, make sure you register, come along for the event. If you're a budding speaker, submit as well. We haven't finalized the lineup as yet, but we look forward to all new speakers who would like to participate in this event. So have a look, register, and stay tuned for updates as they come out. So with that, I'd like to hand over to Will to start today's session.
Awesome. Let me share my screen. Is that coming through?
Yes.
Fantastic. Sweet. All right. Good afternoon, everyone. And welcome to this session developing hybrid transactional analytical processing solutions with Azure Cosmos DB and Azure Synapse Analytics. My name is Will, and I'm an Azure integration consultant working for Datacom out of Auckland, New Zealand. I'm really excited to actually be talking to all of you today about this feature, which came into preview at Build 2020, I believe. Whenever I do a session about Cosmos DB, I'm always interested just to kind of go around the room in the audience and see who's heard of Cosmos DB, who's using it in anger. If you're just using it to develop any prototype applications, you've heard of it, but you're not quite sure what it does and what its purpose for. I like doing that just to get an idea of who I'm talking to. But since I can't see you all in person today, what I'm going to do is I'm just going to set expectations right now by saying that you don't need to have had any experience in Azure Cosmos DB or Azure Synapse Analytics for that matter to be able to follow along. It doesn't matter if you're an expert, it doesn't matter if you've just heard about it, or if you haven't used it. This session is just designed to show you how you can build hybrid transactional and analytical solutions easily using Synapse Link for Cosmos DB. So with that in mind, what I'll do is I'll do like a quick overview of what Azure Synapse Analytics is and what Cosmos DB is. And then I'll talk a little bit about what it was like to perform analytics on data in Azure Cosmos DB before Synapse Link was announced, and what a pain it was, what that caused, what kind of pain and difficulties that caused to developers and business analysts alike. And then we'll get into the meat of the presentation. We'll talk about what Synapse Link actually is, what it is for Azure Cosmos DB, what it means, how it works, what the Azure Cosmos DB Analytical Store is, how that powers Azure Synapse Link to do what we need it to do, what benefits it provides us, and in what situations we'd actually use Azure Synapse Link. And then we'll go through a demo. Oh, hello. Then we'll go through a demo. Hopefully the demo overlords are kind to me today, and I'll actually show you how all the parts work together. So as we go along, feel free to pop any questions in the chat, and then after I've done my talk, I'll do my best to answer them. Now, with that out of the way, let's start off by introducing Azure Synapse Analytics and Azure Cosmos DB. So performing analytics in the enterprise today really requires operating on not just a huge amount of data, but also a variety of different data types. And in the past, what we'd have to do is we'd have to kind of pool technologies together like Spark and SQL in kind of a very isolated and clunky way, and then try and integrate them into our pipelines in order to actually gain the insights that we need to gain in our data, wherever that data was sitting in relational data stores, whether it was sitting in data lakes, if we had a data lake at that time, whether it was sitting in NoSQL data stores, wherever, it was kind of clunky and just all out of place and very forced. And these systems are complex. They take time to build properly in order for us to actually build systems that can give us the intelligent insights that we need into our data. What Azure Synapse Analytics is, it's an integrated analytics service that can actually help accelerate this process. And it helps us to actually scale this process across our data warehouses and our big data systems in the format that they are. We can use SQL and Spark within the same place and use them within pipelines to actually orchestrate the movement of our data. Synapse comes with a web native studio user experience that actually provides us like a single experience for managing, monitoring, securing, and coding our data pipelines and projects. Essentially, it's really just a unified experience that brings everything that data engineers need in one location. It also integrates really well with Power BI, and it has also built-in support for Azure ML. So Synapse is really effective for allowing developers and data engineers to build a complete analytical solution, depending on what our project requirements are. And for those of you who don't know what Azure Cosmos DB is, so Azure Cosmos DB is Microsoft's globally distributed multi-model database service, and it allows us to elastically and independently scale both throughput and storage to any Azure regions worldwide. Using Cosmos DB, we can actually build databases that use a variety of different data models. So say, for example, we're building applications that use document data. For that, we can use the SQL or MongoDB APIs. Perhaps our applications are working with columnar data, and for that, we can use the Cassandra API. For those of you who have used Azure Table Storage, what Cosmos DB provides is a table API, which is essentially what I like to call Azure Table Storage on steroids, and it's essentially just a globally distributed service of Azure Table Storage that's super quick and really super simple to work with. Or perhaps we're working with graph data within our applications, and for that we can use the Gremlin API to do that when we're building graph applications with Cosmos DB. Cosmos DB provides us with the ability to build highly responsive and available applications worldwide, ensuring that no matter where our users are, we can bring their data as close to them as possible. There's guaranteed low latency for both index reads and writes at the 99th percentile for all regions around the world. Cosmos DB is a foundational service in Azure, so it doesn't matter which region you're deploying your infrastructure to, or which Azure data center you're deploying your infrastructure to. No matter where you're deploying it, you can deploy Azure Cosmos DB, and that allows, with the guaranteed low latency for index reads and writes, that allows us to build applications that have really fast querying capabilities. There's also multiple consistency options. So traditionally, we'd have to do a bit of a trade-off between eventual consistency and strong consistency. And what Cosmos DB provides is 5 well-defined consistency options for us to choose from and for us to tune depending on the requirements of our applications. And with some caveats, there's no schema or index management. So right out of the box, Azure Cosmos DB indexes all of our data for us, and it's a NoSQL database store, so we don't need to. There's no strict schema management requirements. Now, I say with caveats because depending on the nature of your applications and depending on your querying, the types of queries you're going to be performing in Azure Cosmos DB, you may want to do some custom tuning for your indexing and how you index your data. And just because it's NoSQL doesn't mean the idea of data modeling goes completely out of the window. So there are some caveats to it, but out of the box and nice and simple and straightforward, there's no intense schema or index management required. And Azure Cosmos DB can be used in a variety of different scenarios. So we might have IoT applications that require us to read devices from data from devices from all across the world, and we can use Azure Cosmos DB to essentially provision or replicate our data to different Azure regions around the world to enable them to be as close to our device as possible. We might have gaming applications with users all across the world. We might be developing retail e-commerce applications with users, and we need to bring their data as close to them as possible. Essentially, in a nutshell, wherever your users are and wherever your users are, Cosmos DB is a fantastic service that brings a huge amount of benefits for developers who want to work with a database quickly that can scale globally and quickly and easily. And thanks to its read and write capabilities, Cosmos DB is really a first-class service when it comes to performing transactional workloads. However, when it comes to performing traditional analytics on our Cosmos DB accounts, there were usually some complications that we would encounter. Now, at this stage, it's really important to discuss the concept of throughput in Cosmos DB and really gauge what that is, and that's how we can, and how that affected our ability to perform analytics on our data. So when we talk about throughput in Cosmos DB, we come across this idea of request units. And request units are essentially the currency for performing operations on Cosmos DB. And if you have a look at documentation online, it's usually referred to as RUs for short. Essentially what request units are, they're just an abstraction of system resources required to perform operations against our Cosmos DB account. And this is across all of our APIs. So it doesn't matter if you're working with the SQL API or table API, the idea of throughput is consistent for all APIs. And when we perform actions against our items in Cosmos DB, this will cost request units. Now, in terms of provisioning throughput in Cosmos DB, we can set this at either a database level or a container or a table level, depending on our requirements. And we can set this either manually. So essentially, this means we can actually set it at a very hard level. So we have define an upper limit, and essentially, if we perform operations that exceed that upper limit, we'll get some throttling. Or we can use a relatively new feature called auto scale. So we could essentially say to Cosmos DB, all right, this is the maximum level of request units I want to spend on this database or this table container. Essentially, if my operations reach that level, scale up to that level for me. And if not, rest at 10%. And those are just a couple of ways that we can actually provision throughput. And this comes with limitations, and it would put us as developers in a difficult spot. In order to perform bulk analytics on our data, essentially what we need to do is we need to provision extra request units just to cover this, which is just really basically just a waste of money and resources. In Cosmos DB, like I said, indexing is automatically managed for us. But depending on the size of our documents and the consistency level that we set our Cosmos DB accounts to be at, this also has an effect on the amount of request units we can consume. Now, I did mention a little bit that we can customize our indexing policies through a variety of different strategies, along with creating composite indexing as well for certain properties, depending on how we're going to query our data. But essentially, this is indexing in Cosmos DB is managed through JSON files. And you can imagine the amount of time that you're going to be consuming or just spending just trying to fine tune your indexing strategy just to perform a couple of bulk queries here or there. It's time consuming, and it's a little bit wasteful as well. The way that partitioning works in Cosmos DB, so essentially, just to describe it really, really quickly, we use partitioning in Cosmos DB to scale our containers. When we create a container in Cosmos DB or a table, we essentially define a partition key. Now, when we add when we add a document to our container, and it has a property that matches with our petition key, we're essentially saying we're petitioning on that property key. Now, as you can imagine with analytical workloads, we don't usually, when we're doing bulk analytical workloads, we don't usually limit it to a single property. So say, for example, if I had a container full of hotel names and we were petitioning on city name, we would want to, if we were performing bulk analytical workloads on our hotel container, we wouldn't just want to limit our analytical queries to just one location. We want to essentially perform that query on all of our hotels if we needed to. And essentially, when we do this in Cosmos DB, this is something known as a cross-petition query. And essentially what happens with this is when we do a cross-petition query, we're essentially performing the same query on each petition. And depending on how much data you have, how much how distributed your data is across all your petitions, you can experience throttling, something called hot petitioning, where one petition kind of hogs the resource over other petitions. And essentially with cross-petition queries, you have to wait for each query to finish on each petition. And depending on how your data is petitioned, this is very compute intense and very it can take a long time to get back some simple results if your query does actually even return results at all. Now, data stored in Cosmos DB containers is stored in an indexed row-based transactional store. And this row store format is really, really good for us when we're performing transactional workloads because it's designed to allow fast reads and writes. But as our data sets grow, performing complex analytical queries can be expensive. So in order to actually do this before Azure Synapse Link, we'd essentially find ourselves in situations where we'd have to build pipelines to extract our operational data into a separate data layer, such as SQL databases or data lakes. And we can do this. There are mechanisms available to do this. We can do this via the Cosmos DB change feed, which is essentially just kind of like an event listener that listens to your container, and you can perform actions based on what's happening on that container. Or we could even do some bulk copy data jobs using Data Factory to actually extract the data out of Cosmos DB and put it into a separate data layer that's actually more optimized for analytical workloads. But as you can imagine, this can increase in complexity, and this does cost resources as well. So what we need is a really simple and straightforward way to actually perform analytical workloads on our data in Cosmos DB without wasting time and resources. And this is where Azure Synapse Link comes in. So Azure Synapse Link solves our analytical requirements for our data in Cosmos DB. Essentially, it's a hybrid transactional and analytical processing capability that allows us to run near real-time analytics over our operational data in Cosmos DB. Synapse Link integrates Azure Cosmos DB and Azure Synapse Analytics seamlessly and really well together. And this is performed through a feature in Cosmos DB called the Analytical Store. And essentially what the Analytical Store is a fully isolated column-based store that enables us to perform analytics on our data in Cosmos DB, requiring no ETL on our part or on our operational data. With the Analytical Store, we can use Synapse, Spark, or SQL to run business intelligence, machine learning, or analytical workloads without affecting the performance of our transactional workloads in Cosmos DB. So the Analytical Store has just come out of preview now. I think it's now public, and essentially this store addresses the complexity and latency challenges that I described earlier with our row store and ETL pipeline. Essentially what happens is when you enable the Analytical Store on your containers in Cosmos DB, the column store automatically syncs your operational data into a separate column store, which is more suited to analytical queries. This is asynchronous and it requires no ETL, so you don't have to create applications using the change feed. You don't have to use Data Factory to transfer it from the row store into the Analytical Store. Essentially, what it will do, as you persist data into your transactional store, AutoSync will then sync that data into your Analytical Store. And this is done within 5 minutes. There's like a 5-minute time period that this happens. So it's near real time, depending on your definition of real time capabilities. And with this, with the Analytical Store, there's now a new feature called Analytical Time to Live. So for those of you who are a little bit more familiar to Cosmos DB, may know that Cosmos DB has this this feature called Time to Live configuration. And essentially what this is, we can actually set this either as an item or a container basis for our transactional data. And this is set in seconds, and we can say, okay, after so many seconds, I want Cosmos DB to automatically delete or expire this data for me. And this option is now available for data sitting in our Analytical Store as well. So inserts, updates, and deletes to operational data are synced to the Analytical Store, irrespective of our transactional TTL. And we can actually specify how long we want to retain our data within the Analytical Store using the analytical time to live. So you can have situations where you might have a container in Cosmos DB that's optimized purely for writes. And so when it's performing transactional workloads, we have a container that's just optimized for write capabilities. We enable the Analytical Store on that container. So as we write into our Cosmos DB container, we can set the transactional time to live at a much shorter time, say 10 minutes. So after 10 minutes, we write the data where you can expire that data automatically, and we can keep it forever within our Analytical Store. So if we wanted to free up some storage within our transactional store in Cosmos DB, we can set that data to expire after a certain amount of time, and we can then retain it for longer within our Analytical Store. So that opens up having the ability to set the time to live for different values for both the analytical and transactional store. I think really opens up some interesting opportunities for us to perform analytics on our data. So just to kind of summarize some benefits of Azure Synapse Link, Azure Synapse Link allows you to directly access your Cosmos DB Analytical Store without having to create any complex ETL jobs. I have been in situations in the past where before Azure Synapse Link, we've had to develop Azure functions to utilize the Cosmos DB change feed to actually transport that data from Cosmos DB, or copy that data, it's probably a better way of putting it, from Cosmos DB into a more analytical friendly store. And now with Synapse Links, there's no need to do that. Any updates on our transactional data will be visible to our Analytical Store within near real time as well. So there's that 5-minute period, but I have noticed when playing around and testing with this, it is a lot quicker as well. So within that 5-minute time period, it is guaranteed to be synced from your transactional data store into your Analytical Store. So we can do that without having to develop any ETL jobs on our part. ETL systems usually take a while to get the result that we want due to the complex nature of ETL jobs. So we might be doing some transformation, we might be only including certain amounts of data, but depending on what we're trying to do. But with Synapse Link, we can actually analyze our operational data within that near real-time time period without having to remove any data just to try and kind of like force a view of our data to our analysts or BI engineers or whoever, which I think really opens up some quite interesting analytical scenarios for us now that we have access to that raw transactional data without having to affect the workloads, our transactional workloads through Azure Synapse Link. So just some more scenarios of where we could actually utilize Azure Synapse Link for Cosmos DB. So say if you're an existing Cosmos DB user and you want to run analytics, any type of BI or machine learning over your operational data, Azure Synapse Link is fantastic for that. In those scenarios, Synapse Link provides us with a more integrated analytical experience without impacting our transactional store's provision throughput. So say, for example, you're running analytics or BI on your Cosmos DB operational data using those separate connectors or using separate mechanisms, or you're running ETL processes to actually extract the data from that and then put it into a separate analytics system. Thanks to the web portal and thanks to just kind of like a really easy integration between Azure Cosmos DB and Azure Synapse Analytics, it provides a more integrated environment for you without having to engineer all of these different mechanisms just to perform some analytics on our data. And this is all happening without actually impacting the throughput that we provision onto our transactional store in Cosmos DB. Cool, so I'm going to kick off into a demo now. So what I might do is just zoom in a little bit here. Try 125. If it's not coming through, do let me know. But what I'll do for now, so with this is my Azure Cosmos DB account. And what I've done ahead of time, I've actually enabled the Azure Synapse link feature on. I think for for accounts that haven't had this feature enabled on, you can actually just come in here in the features setting in the portal and just essentially just turn it on and just enable Azure Synapse link for your Cosmos DB environment. You can also do this through infrastructure as code as well. So I use Terraform quite a bit. And I think very, very recently, you're able to actually provision Cosmos DB accounts that have this Synapse link enabled anyway. That you can actually enable Synapse link on your Cosmos DB accounts when you're provisioning it through infrastructure as code. Okay, so I'm going to go into the Data Explorer now. And I'm really hoping that I've got this container here containing a bunch of health information. So I'm a Fitbit user. I wear my Fitbit device when I'm working out, when I'm sleeping. I also have a Fitbit application where I track my food and track how much water I've been drinking, etc., etc. And essentially, I've got a bunch of functions that listen and basically make calls to the API and essentially persist that data within Cosmos DB. And what I've done here is I've petitioned my Cosmos DB container using this document type feature. So you can see here for each document that I add to my Cosmos DB container, I'm petitioning it by document type. So I've got my sleep document here, I've got an activity document, nutrition document, etc., etc. So when I'm performing queries, say if I want to go where c dot document type is equal to c dot, oh, hang on, is equal to, I'll just say sleep for now, working on, sleep. So if I apply that filter, I get all the documents that are of document type sleep back to me. And here we're actually performing a query within the scope of a petition. But if I open up a new SQL query and if I just do a select all, even though you shouldn't do a select all, and I just execute that, essentially what I've done here is I've just essentially performed a cross petition query. So I'm querying all my petitions. Now here it's it's fairly quick because we're actually performing it directly against the engine. But if we're performing this type of query in our applications, we're going to experience some latency. And it's going to be cause some performance issues for us as our data grows within our container. But what I've done is for this container, I have, the analytical store is not enabled on this. Oh, that's annoying. Okay. So what I can do, we'll create a new container with the analytical store enabled. So I'll use my existing database and I'll just call this a test container. What I might have to do, also petition this using the document type. I'll also use autoscale, and then here I'll just enable the analytical store. And essentially, what I'm doing here is I'm just enabling that analytical store capability so we can actually perform that real-time analytics on our operational data. I'll just create you. Hopefully it won't take too long. And what I'm going to do is I'm going to just copy and paste some of these documents over to that new container. Okay, so I'll just come into here to the new container. I just want to create a new item. Hopefully that works. Yep, sweet. What I'll do is I'll remove that. Just add another one, but of different type. So I'll just add a nutrition one as well. I won't make all of you watch me manually upload new items. I'm not going to do that. Sweet. So I've got a couple of items now, but what I want to show is that if I go back into scale and settings, if I just go into my settings here we can set so this time to live. So here I've got it off by default, but I could switch that on. Say I could automatically delete items based on this after 10 seconds. And then on this analytical storage time to live, I could leave it on, but just have no default. Or I could set that to -1, just tell it to store data in the analytical store forever. So this provides us with some granular control over how long we want our items to live, either in our analytical store or our transactional store. So you can really optimize your transactional performance by deleting the automatically deleting items in your transactional store really quickly, and then for your analytical requirements, you can retain that data for a period of time or forever, so you can actually perform. You can still perform analytics on that data that's been synced to the analytical store. Cool. So now what I'm going to do is I'm going to switch over to Synapse Analytics. And here's my Synapse Analytics workspace. So essentially, when we connect to our Azure Cosmos DB environment, we essentially need to create a linked data source. So here I've created a bunch already, but what I'm going to do is I'm going to create a new one. And here I'm going to, before I actually kick off into this, let me zoom in a little bit. And we'll connect to an external store. Now, at the time of recording, we can connect to Cosmos DB accounts that have either got the MongoDB API or the SQL API enabled on. If you're using the Cassandra API for your Cosmos DB account and you want to use Azure Synapse Analytics to analyze your data, that is under gated preview. So you can reach out to the Cosmos DB team for that and just ask them to open it up for you. I think graph data is the one they want to focus on next, and I don't have a timetable for the table API. But anyway, my Cosmos DB account is a SQL API account, so I'm just going to click on that. And we can choose a name, so I'm just going to go data Downunder test. We can either connect to our Cosmos DB account either via connection string or Azure Key Vault. So what I'm going to do, just pick my, not pay as you go. Haven't got an account in there. Pick my Cosmos DB account from earlier, and I'll connect to my health database. Just test the connection for that. Make sure it's all working. Sweet. So our connection is successful, so I can go ahead and create that. Fantastic. And what I might need to do, just refresh that. And there we go. So there's my new, there's my linked service to my Cosmos DB account. So if I open that up, hopefully I should see 2 containers. Fantastic. So, cool. I've got records and I've got a test container as well. Now, if you notice this little bar chart here, you see that when we link our Cosmos DB accounts to Azure Synapse Analytics, we're linking our accounts and not specific databases, or we're linking as specific databases. But essentially, what I'm trying to say here is if you have a database with multiple containers sitting underneath that database, you don't have to have the analytical store enabled for all of those containers. So you might have one container that's optimized purely for writes, and you want to enable the analytical store onto that container so you can actually perform analytical workloads on that. But you might have another container that kind of presents a materialized view of your data, and you're serving that via a web application or a mobile application, but you don't have to have the analytical store enabled on that if you don't want to. But what I'll do, I've got my records one here, and I'm actually going to create a new Spark script or Spark notebook. So hopefully my Spark cluster is still running. What I'll do is I'll just click that, and I'll just run on to that. And essentially, what I'm doing here is I'm loading the data that's sitting within my records container here. I'm using this link service, data Downunder test, putting it in this Cosmos operational formats, and I'm loading that into a data frame called DF. Hopefully that won't take too long. Oh, it's starting the Spark session, so it might be too long. What I'll do is I will actually do some coding in the meantime as well. So if I create another code cell, what I want to do is from this data frame, say for example, I just want to get all the records, have sleep. So if I select that, when we load this up into a data frame, we'll also load up the system properties that you see here. So if I go into just the sleep document for a moment, essentially you have, whenever you add an item to Cosmos DB, you'll have these system generated properties. Now, in terms of analytics, that might not be so useful to us. So for example, say what we might want to do is we might just want to get the sleep date and time in bed, for example. So if I go df, oh, hang on, accidentally pressed sleep dot date df sleep dot bed. I'm just going to select where df df document type is equal to sleep. Okay, so that's executing that job now, which is good. Display def. Cool. So see here when we loaded our container into this data frame, you see we've got all of these system generated properties here. So ID, the timestamp of when the document was added, etc. So the actual document itself, document type, e tags. It's brought back our activity and nutrition. Anyway, and we don't really want this, so essentially we can just run this, and hopefully it's going to give me. Wait, what? Try not cannibalizing that. There we go. That's better. Cool. So here we can actually start to extract some the columns out of our data frame, and essentially we're performing all of these analytical workloads without affecting our transactional performance. Probably should have put a limit on that, but never mind. Now, say we're performing a bunch of analytics on our data using Spark, we can actually write this back to Cosmos DB. So we can do here, I'll just create a new container. I'll just put, I'll put the petition, and I'll just petition this by ID for now. The example of what I'm doing here is I'm actually loading this data, or writing this data stream from our Spark data frame into an Azure Cosmos DB container. And you might have your analytical team performing analytics on your raw transactional stores, and there might be a requirement from your applications to actually serve that data back to your users in a transactional way. So here I've got my sleep container. So I'll just copy and paste some code. Call this sleepdf. So essentially from sleepdf, I'm going to write into Cosmos, into this Cosmos operational format. Let me just get my link service name, data Downunder, and I'm going to write it to my sleep container that I've just created now. So if I just let that run, sleepdf is not defined. Did I spell sleepdf wrong? Oh my God, capitalization is really not my thing today. Apologize. Let me run that. Okay, so that's executing. So if I go back into my Cosmos DB account, hopefully we should start to see the data that I've manipulated in its glorious form being written back to my Cosmos DB account, to my container. So that's just a kind of a quick demo of how you can actually connect your Cosmos DB accounts to Azure Synapse Analytics. And then using Apache Spark, you can actually perform some analytics on your workloads. So here in this example, I've just read or just loaded the data from my container into a data frame. I've done some basic data manipulation and then written that back to a container in Cosmos DB. But you can imagine, depending on your requirements or how elaborate you want to be with a Spark application, and because of the comprehensiveness of Apache Spark, we could perform all kinds of different interesting and cool analytical scenarios to perform analytics on our transactional data without actually affecting our transactional workloads, which is really, really cool. Cool. So don't start from the beginning. Cool. Sweet. So just some things to note. Like I said, currently this is only supported for the SQL and MongoDB APIs. The Cassandra API is under gated preview. Synapse SQL Serverless might have come out of gated preview. My understanding is it's still currently under gated preview, but I could be wrong on that. When we enable the analytical store, we can't do that on existing containers. So one of the pain points at the moment is that if you have existing containers within Cosmos DB environments, you can't go and turn on the analytical store onto those existing containers. So if you do have data within your containers, there is still that pain point of being able to transfer data from that existing container into a new container that has got the analytical store enabled. But hopefully that pain point will be gone soon. And you can't disable the analytical store after you've created your containers as well. So it's kind of like once you've enabled it, you're stuck. But hopefully that will not be the case in the near future. There's no impact on your transactional stores in terms of request unit expenditure, and the analytical store is currently read only. So we can write back any aggregation results to the analytical store, but say if we write them, hang on. So we can write any aggregation results to our analytical store. Sorry, we can't do that, but we can write them to another container's transactional store, as I showed in that demo, which can be used as a serving layer. So there is that as well. Cool. Well, thank you all for listening. Let's kick off into, I hope that all made sense. Let's kick off into some questions.
Well, thanks, Will. We have got our first question. If you're able to elaborate on the cost implications of Synapse links versus ETL.
Is that in terms of throughput or actual money? Because in terms of throughput, money, fantastic, sweet, following the, so there is you're charged for enabling the analytical store on Cosmos DB from a Cosmos DB perspective. So if you enable the analytical store on your containers, can't quote the exact price, but there is a bit extra that you pay for enabling that. In my demo, I used Apache Spark, and of course, you'd be paying for those Apache Spark pools that you provision for however long you're running it. So there is that cost implication in terms of Azure Synapse link. In terms of ETL, it really does depend on how complex your ETL workload is. So I can give you kind of like an example that I ran to at my previous company. Essentially, what we were doing is we were performing daily extracts on our data in Cosmos DB, and trying to produce. We were using an Azure function to try and produce a DAP file, and essentially we were performing like a select all query on all of the data that had been persisted to Cosmos DB within that day, and when we were first developing this, it was just a nightmare. We were suffering a lot of throttling issues because that processing really does, that obligation sits with Cosmos DB. So essentially we were consuming throughput on the Cosmos DB side. So in order to actually, depending on how many transactions we were processing in a particular day, we would have to provision, we'd have to increase the throughput to prevent any throttling. So within our applications, we would check for essentially a 429 error code, and every time that would be thrown back at us, we would essentially increase the amount of throughput that we were provisioning. And of course, with throughput, you're provisioned at an hourly basis. So you might provision, say, 50,000 request units, and you might only use that for a couple of seconds, but you're charged for the entire hour that you hit that 50,000 request unit level. So that got quite expensive in terms of money. Are there any issues, or is there any issues having applications built on top of Analytical Store? So your applications won't be built on the Analytical Store. So essentially, the Analytical Store in relation to the transactional store is it's an isolated store. So when you're building your applications for Cosmos DB, when you're performing operations against your transactional store. So with the Analytical Store, it's completely isolated from your transactional store, and data gets synced to it. So the answer is, to my knowledge, no. I've never experienced any issues because the applications aren't built on top of the analytics store. Yeah.
Thank you, Will. Does that answer your questions, Ashok? While we're waiting, does anybody else have any other questions from today's session for Will? Either put your hand up, put it in the chat, or take yourself off of mute. We'll give everybody a couple of minutes. Now, unfortunately, we don't have a session next week, but we do have a session in 2 weeks' time. And that session in 2 weeks' time will be on SQL Server configuration with DBA tools and DBA checks from Tracy Boggiano. So please make sure that you, excuse me, you register for that event. And I look forward to seeing you all in a couple of weeks' time. We do still have a couple of minutes, so feel free to bring yourself off of mute if you do have any questions. If not, thank you to everybody for joining us. A big thank you to Will for giving up his time and presenting for us for our first session of May. I found it a very intriguing session, so thank you, Will.
Oh, thanks for having me.
Looks like all of the comments are very positive. So that's a fantastic session. Thank you. As I mentioned at the start of the session, this has been recorded and will be uploaded onto the Data Platform Downunder YouTube channel so that you are able to come back at any point in time and rewatch this session. All right, well, with that, I'll let everybody else get back on with the rest of your day. And thank you once again, Will. Thank you, Martin. Thank you, everybody, for being a part of today's session.
Awesome.
Yeah, cheers,
Thanks,
Warren. Cheers, Will.